Hi guys, I hope you had a good weekend and you are back and ready to learn some math. Like I've told you guys before, my intention with these videos is that you're watching like one a day, kind of as your math block while we're not in school. Really try to keep up with it and make sure that you're using a few hours a day at least as kind of your designated learning time, as like your school time as it would normally be. And my goal here is that your math can literally just be watching these videos and then doing the practice problems that I gave you. And if you guys have like worksheets or anything like that, you can do those as well. But please try to be doing some math every day, because if you don't practice it, you'll lose it, I promise. So make sure you practice. As I promised you guys, today is going to be a review lesson on percents. We've already done ratios and rates, which means percents should be pretty dang easy because we're going to connect them all together. And I've already taught you kind of the general strategy that I use in order to solve these problems. Like I have told you guys a million times, if you have another strategy that you like better, use that. But this is just a review on the strategy that I've kind of focused on in class, and that I think is the easiest strategy to use in order to solve these. So before I even solve a percent problem, I have to first think about like what a percent even means, right? So when I'm talking about a percent of something, I'm talking about a part of it, right? Yes, a part of it. So if I say that I finished 50% of my homework, that means I finished half of my homework. An important thing to recognize is that any entire thing, any full thing is 100%. So the whole is always 100%. What I mean by that is if I completed my entire math homework, I completed 100% on it. If I got 100% on my test, that means that I got every single question right. If I ate an entire pizza, I ate 100% of it. So when I'm thinking about percentages, I'm going to think about these in terms of, again, a fraction, and I'm going to think about them in terms of part over the whole thing. And when I'm talking about, I'm going to move this a little closer, that might make it feel a little bit easier. When I'm talking about percentages, the whole, so the entire thing is always 100%. Let's keep it black. So when I am making my equivalent ratio, my parts always stay on top, my parts stay with my parts, and my wholes stay on the bottom in this situation. So my whole, my entire thing is 100%. This is essentially like the basic setup for how I solve percent problems. Okay, so when I'm given a percent problem, they're going to give me any combination of these missing values here. So the only value that I know for sure is always going to be there and it's always going to be the same is this 100% on the bottom right corner. So when I'm setting up these problems, I'm going to set it up as two fractions equal to each other, which we've seen in all of my ratio and rate problems, essentially, besides like when we were using the tape diagram. But one of my values I already know, no matter what, it's always going to be there. So my first step is always just going to be to plug in 100% on my bottom right corner, because that's always going to be the entire percentage. The whole thing is always going to be 100% when I'm talking about percents. So we know that this is a part, this is a whole, right? This is a part, but you know how when we've been doing like ratios and rates and things like that, so like dogs stay with dogs and cats stay with cats, and what I mean by that is like if a dog's here, it's dog's here, and if a cat's here, cat's here. In these problems, so the part is always going to be on the top and then the whole is always going to be on the bottom, but I want to be clear here, percents are going to stay together on the right hand side. And what I mean by that, so say they ask me what is, or okay, I'm going to use this as a word problem so that it makes a little bit more sense before I get into kind of the tricks and the procedural understanding of this. What is, I don't know why I just started that the exact same way that I just said I was not going to do. Okay, I ate 2 slices of pizza. This was 20% of my pizza. Okay, so I ate 2 slices. This was 20% of the pizza. And my question here is like, how many slices are there in total? So if I'm saying 20%, percents always kind of have to stick over here in the percentage side. So if they gave me 20%, my first step after putting that 100% in is to just put whatever other percent that they give me on top of that. So 100% goes there, whatever other percent goes on top. And now I have to look at whatever other number and I have to decide, is that a part or is that a whole? So I ate 2 slices of pizza. Did I eat the whole pizza? No, I only ate part of the pizza. So since that's a part, I put that on top. And now in order to solve this, you'll never guess. Multiply across, divide by what's left. Solve it, pause, and then come back to me. So if you multiplied what was diagonal from each other, you should have multiplied 2 times 100, which would be 200, divided by 20. If I set that up, 200 divided by 20, the way that I would solve this would be by reducing it, by essentially like dividing by 10. So crossing off a 0 from both. And then I would have 20 divided by 2, which I know is 10. Since I crossed off that 0 here and here, I don't have to bring it back. So my answer is 10 slices. Let's do another example. Okay, I'm taking a 40 question test. So 40 question test. I need 70% to pass. How many problems? That is not neat. Do I need to answer correctly to pass? That is not neat at all. I'm sorry. I don't even know if there's any benefit of me writing that down, but I wrote it down so we can refer back to it. So 40 question test. I'm taking a 40 question test. I need a 70% to pass. And I need to know, essentially, if I'm taking this, how many problems do I need to get correct in order to pass? Because knowing 70% is not helpful for me unless I know what that actually equates to. So what is that, like how many questions do I have to get right? So my first step is to set up my fractions. And now I know my bottom right corner, automatically for start out, it's always going to be 100%. And I'm going to look in this problem and see if there's any other percentage in there. And I'm going to be like, okay, yeah, that has a percentage sign. 70%, so 70% is going to stay over here. And now I have to find my other number. So my other number is 40. Okay, it's a 40 question test. Is that a part of the test or is that the entire test? If it's a 40 question test, that's the entire test, right? Remember, it's always part on top. I'm actually going to write this over here so that we don't forget. Part over whole. So if that's the entire test, that's going to go on the bottom. Now I have 3 values, so now I can multiply across, divide by what's left, pause, solve it. So if you multiplied the diagonal, so that's 40 times 70, you should have got 2,800. The way I solve this may not be how you solved it, which is totally fine. I'm just showing you like how I made sense of it in my head. I did 7 times 4, which was 28, and then I added those 2 zeros back in. And now I still have to divide by what's left. Make sense of that, right? If I had just stopped at 2,800, if I have a 40 question test, does it make sense that I have to get over 2,000 questions right? No. So if you got that, make sense of that. Think, does that make sense? Can I ever get 2,800 questions right on a 40 question test? Nah, that's gotta be a lot of extra credit. That's not right. And so then see, what step did I miss? Dividing by what's left, which would be dividing by 100. If I'm looking at this personally, I'm gonna look at that and cross off 2 zeros from both. So now I have 28 divided by 1, which is 28 questions. So that means that in order to pass this test, I would need to answer 28 questions correctly. Okay, in some problems, they're not going to give us the percentage. It's going to be our job to solve the percentage. And actually, most times, that's probably what you're going to see when they're asking you to find percent, obviously. That's what you're finding is the percent. Okay, so in this situation, I ate 12 out of the 16 pieces of candy. What percent did I eat? Okay, so I know that I'm solving for percent. So if I know that I'm solving for percent, I'm going to set it up like this. I know for sure 100% goes in the bottom right corner. And they're asking us what percent did I eat. I don't know this. This is kind of my question mark. I don't know. This is what I'm solving for right here. I have no idea what the other percentage is. That's what my goal is to solve. So now I have to see my other 2 numbers, and I have to see where do those fit into this equation. So I ate 12 out of the 16 pieces of candy. What percent did I eat? So my two other numbers that I have are 12 and 16. So I ate 12 pieces of candy. Did I eat all of the candy? No, I only ate 12 out of the 16 pieces. So 12 would just be a part. That's just some of the candy. I didn't eat all of it. This is just some of the candy. Hi, Chumpy. Hi, Chumpy. Do you know percents? Nope. Okay. All right, and out of the 16 pieces of candy, so all of the candy that I had, total I had 16 pieces. That would be my whole, right? So this down here would be 16 pieces. So now in order to solve this, like I've done every time, multiply across, divide by what's left, pause, solve that. Okay, so if I'm solving that, my first step is to do 12 times 100. If I'm multiplying any number by 100, I'm literally just adding 2 zeros to the end of that number. And you can even think about that as 12 times 1, just 12 times 1, which is 12. Add those 2 zeros back in, 1200 or 1200. But I still have to divide by what's left. I still have that 16 to divide by. Now, I don't expect anybody to know their 16s, so I made a chart of my 16s, which I think is a really awesome strategy, like I have told you. Make a chart of your 16s so that you can use this to reference. It's more organized, and you're more likely to get the correct answer. So I'm going to look at this, and I'm going to say, can 16 go into 1? No. Can 16 go into 12? Nope, 12 is still too small. But can 16 go into 120? I'm going to look at my list and see if it can go in, and I'm going to say it can go in 7 times, because that is 16 times 7 is 112. 0 minus 2, I can't do that. I have to borrow. 10 minus 2 is 8. 1 minus 1 is nothing, and another 1 minus 1 is nothing. So I have to bring down my next number. Can 16 go into 80? If looking at my chart, yep, it can go in 5 times. 16 times 5 is 80. 80 minus 80 is 0. I have nothing left to pull down, and my remainder is 0, so I'm done. Which means that my answer is 75. Since it is going in this section right here, I have to keep that whole percentage, that same unit. So my answer is 75%. So what percent of the candy did I eat? 75%. Okay, when we're doing percent problems, they're not always going to give them to us in context. So what I mean by that is they're not always going to give us a word problem to where we can just sit there and make sense of the problem and be like, is that a part? Is that the whole? Is that the entire thing? I don't know. So a lot of times they're going to give us things that say something along the lines of, what is 25% of 80? So I'm going to write that down. Of 80. So when we are solving these problems, and I'm looking at my normal like fraction or my reference point, which is part over whole, another reference that we really should be using is over of. So what that means is that when you see a number after is, it goes on top. If you see a number after of, it goes on the bottom. So if I'm asking for percentage, which I am, I'm still going to set this up the same. I'm still going to put 100% on my bottom right. I'm going to look and I'm going to see, is there any other percentage in this problem? Yep, there's a 25%, which I know goes above the 100%. And now I have another number. This is really shaking. I don't know what's going on. Oh, it's because it's broken. The other number is 80. So I'm going to look at that. Of 80. Of goes on bottom because I'm finding 25%. So it says, what is 25%? I don't know. I don't know what the part is. I know what the whole thing is. The whole number is 80 because it's saying of 80. But I have no idea what that 25% is. That's what I'm searching for, is that part. So in order to solve this, like all the rest of them, multiply across, divide by what's left, pause, solve. Sorry if things look a little different. I had to fix the board. Okay, so if I'm multiplying across, I'm going to do 80 times 25 first. 0 times 5, 0, 0. Next line, adding a 0. 8 times 5 is 40. 8 times 2 is 16. Plus 4 is 20. I'm adding down. It's 2,000. But that's not my answer. That doesn't make sense. 25%, a part of 80 is 2,000. No, that's way too big because I still have to divide by what's left. So now I have 2,000 divided by 100. If I'm looking at this, I'm not about to go through that process with all the zeros. I'm going to cross off 2 zeros there because I have 2 zeros, and I'm going to cross off 2 zeros there. Now I have 20 divided by 1. 20. Easy. Way easier. So my answer in this problem would be 20. Okay, so the other way that you might see this being worded is 40% of what number is 16? So this one's slightly different, but I'm still going to set it up the same in that I keep 100% on my bottom right corner. I look for any other percentage in the problem. They're giving me 40%. That obviously goes on top of my 100% because my 100's staying over here to the right. And now I have to look and say 40% of what number is 16? So the 40% is 16. That means those are the parts together. 40% is 16. Is means equal, right? So 40% equals 16. Those are staying on the top because they're both the parts. Remember, is over of. Now in order to solve this, I just multiply across, divide by what's left, pause, solve it. Okay, 16 times 100, I would do 16 times 1, add those two zeros back in, that's 1600. Divided by 40. I'm going to make this easier for myself by reducing this, by taking off a 0 from both sides, because I don't have to think about it again. I took off the 0 from both sides. I divided by 10, essentially. I just made it an equivalent fraction, so I don't have to worry about those again. So now how many times can 4 go into 16? 4 times. 4 times 4 is 16. If I bring down this and I have a double 0, that means I have to bring a 0 back to the top. 4 times 0 is 0. Now I have a single 0, so now I am done. Another way you could have looked at that is 16 divided by 4 is 4. Add that 0 back in because I didn't erase it. I just covered it for a second, so I do have to bring it back. Either way, you should get 40 as your final answer. Okay, there are a lot of practice sheets, worksheets for percents online. So I'm just going to link the website that has, I think, the best examples of these problems down below in the description box. But I'll just also walk through it here. So it's go to commoncoresheets.com. On the left-hand side, you'll find percents, and then it's the finding percents worksheets. But I'll link it down below. Again, really try to practice these problems. Get as much practice as you can while we're on break. Make sure that you're checking your answers. I would even have somebody else check my answers for me. Use this as a normal assignment. You guys have gone over this in class, so this is just kind of a review. But of course, if you guys have any questions, comment them down below. Message me. You know the drill. But make sure that you're practicing your math every single day, except for on the weekends. I wasn't here on the weekend. I get that. You can have a break then, okay? I'll see you guys soon. I'm actually going to go, I think, into statistics next. I think we're just going to jump right there. So, I'll see you guys later. Bye.